Okay, so I'm just going to take you through some of the stuff to make the mini button. So this is a version of the button that hasn't got an integrated screen, so it's smaller and cheaper to make, and you just plug it into a telly. So the laser cut parts, you have two sides. One side's got a little access hole to try to get to the SD card. There's a front panel which has got the picture of the button on. A back panel which has got, again, an access hole for the HDMI and the power. The top panel's got the hole in it that the button will actually go through, and the dome will sit on top there. So that's how that works. I'll look at that in more detail. And then this piece is what the button mechanism rests on. So the foam that acts as the spring sits on there as a hole, so we can get a wire through. Then there's the base pieces. I've got two versions of the base piece. One for an older Raspberry Pi, which has got the two mounting holes, and it's also set much more to one side, so that there's room on this side to get the power in. It does make, and it also means the SD card, which is bigger here, is also within the box. And then for new Raspberry Pis, we have this version of the base, which is more convenient because the power comes up this side. Also, that means that in this unit you'd actually be able to still use the USBs potentially, depending on the connector you were using. Some other parts, there's some tiny little feet, and the purpose for these feet is to stick on the bottom, just to kind of give room for the screws, so that it's not rocking on the table too much. Then there's the 3D printed parts. So there's this piece which holds the electronics for the lights here, and then the dome goes on top. Then, as I showed before, that goes through the top piece and meets with this bottom piece, and they get glued together, and then the whole thing sits on a foam spring, which in turn sits on this base piece, so you kind of get this action. Some other bits you're going to need. You need some copper foil. This is copper tape, actually. We're going to use that to make the internals of the switch mechanism. You'll need some Veriboard, which we'll use to hold the LEDs inside the button. So that'll go like that. That's how the button's going to light up different colours. We need probably one or two power transistors or diode pairs or something like that. You'll need some nuts and bolts just to hold the Raspberry Pi in. I suppose you could use glue gun. And I'm also going to stain my button blue, so I've got some blue wood stain. You'll also need glue and wires and things like that, obviously a Raspberry Pi. So I guess one thing that's just worth showing is how this all kind of comes together. So if we take one of the base units, I said before, it's going to sit on some feet. So those feet will get glued to the bottom. So if we just put those there for the time being. Usually the way I put this together is I would start by putting the button support into the side pieces. With these finger joints, it's usually a good idea to try to start at one end and then ease it in that way. When I'm actually putting this together properly, I'll finish that together either with a small amount of pressure from a clamp or with a light tap of a mallet. Again, and then here comes the other side, and again I'll start that from one end. And then in the real thing, I'd close that in properly. Some of these pieces obviously have a right way round. This side piece has to match up with the SD card slot, so I have to start that the other way around. So you're going to put that in there. So that whole unit will then go onto the base. The front will join in. And then the back will go on. Just there for the time being. When I'm actually putting this together for real, I'll get it to this point, and then I'll glue here and here and here and here. I won't bother gluing this button support in there, that can just sit by itself. And to begin with, I won't glue the top or the bottom on. I might just put them in place so everything all lines up. Then once the glue's set, I'll be able to take the top piece off and to start to build the button mechanism in. So we'll be able to, and we'll probably have a piece on this later. So yeah, so I'll do that, and then the last thing I'd glue in place would be the bottom piece. Once it's all working and the Raspberry Pi is all wired in, then I'd glue the bottom in. Not that it's not possible to access the Raspberry Pi once the bottom is glued in, because it will screw out. It's just to be much more convenient to be able to do it. Without using the screwdriver. Okay, so the next step is I'm going to go take this all to pieces and glue it and paint it blue, or stain it blue. Actually, this is a wood stain, and then we'll come back and put that together. Well, I guess one thing I haven't shown is also in the 3D parts, in the laser cut parts, there are some little wooden spaces which I've used just to offset the Raspberry Pi board from the wood, so that you can maybe just see that in there, that they're part of the kit as well. Okay, yeah, so next time you see this, it should all be blue, and we'll start sticking it together. Hi, I thought we'd just take a quick look at the finish of the stained parts before we start putting it together. I really like the this wood stain because you can still see it colours the button blue, because like it is in the TV show, but it still allows you to see some of the grain features of the wood, so it still feels quite nice and wooden, and I think it looks really quite attractive. So yeah, I've stained all the outside parts. I didn't bother staining this piece because it's only going to ever be inside. And I've stained most of the parts on both sides, the inside and the outside, because there'll be places you can see in when you're using it. I thought it'd be neater. One thing to note, that sometimes when you're painting it, when you're staining it, the stain will come around to the other side, so as you can see on this one. And so I've tried to make sure that always happens on the inside, so I did the outside first, and then I did the inside just with quite a light stain and made sure that no drips went round, because obviously it's fine. I mean, it's nice to have the inside blue, it's not completely necessary. If I'm going to have any blotchy bits like here and here, I want them to be on the inside. Okay, so we can start trying to put this together. Let's do before in the kind of dry run. You start with the two outside pieces. It's probably a good idea to kind of line them up with the base, so you can kind of picture that. And as I said last time, well, I start by putting this piece in, and I usually find that it works best if you start at one end and just kind of push it snug. So that works quite well. So that's quite a good fit. And then we can do the other end, other side, and again, just try starting at one end of it and just kind of push that home. That's a little bit tighter. We can try applying a little bit of force with a quick clamp. See if that's going to help. It might do. It might not. Another thing to try is, it can be quite helpful just to give it a light oops, a light press with a mallet. Oh no, but in this case, I think we can achieve quite a lot just with whacking it with my hand. Okay, so that's the two sides. It's like a TIE fighter from Star Wars, doesn't it? And they should go snugly in the bottom. You notice there's no glue yet. Cool. So with the bottom in, definitely not glued on. And then offer up the front piece. And again, it's always good to start at one end. And yeah, that looks quite good. And then the back piece. And oh yeah, so that's really quite tidy. And you can see, I mean, looking in, you can't see much blue, but I think painting staining inside didn't take long. It does just make it a little bit more professional. And then the top piece. So I was saying, with the top piece, I didn't bother staining the inside because you definitely won't see that, and that's where the copper contacts go. So just pushing that into place for the time being. Again, no glue, but that just makes sure that everything's square and it will go together nicely next time. That's a bit tight, that one. There we go, there we go. Okay, so that's all button kind of dry press fit together. You can see that looks pretty good. So now, if I just prise the top off, and if I can get the bottom off as well, that would be good. Kind of just, there we go. So we know it's all going to fit, it's all kind of square. So the next thing we want to do is just put a bit of glue in. So I'm using the Gorilla Wood Glue. I find this quite a good glue for gluing ply. And my technique for gluing it is just, I'm going to take the nozzle and I'm just going to squirt a little kind of bead of it into the vertical upright corners. Also got a bit of a paintbrush, that kind of old paintbrush, which I'll just use to kind of persuade that into the joints a bit more. Kind of, yeah, do that. I find it's quite a strong glue, and the finger joints are pretty strong. Anyway, oops. I tell you what, it does no harm just to the thing I want to really avoid is too much glue on the outside, because that can be a real pain to clean up. So let's offer that back up into place. Yeah, so there's a bit of glue got on the outside there, which I'm not always that happy about. But if I just kind of try to tidy it inside a bit. So sometimes the finger joints, the box stop pie generator, a bit tighter than this. Maybe this would be a good opportunity just to stick a bit of clamping force on it, just to hold it together while the wood sets up, while the glue sets up. Maybe I'll do it that way. There we go. It's quite good. And then in the meantime, I'm just going to go find a damp rag and... Actually, no, I think... Yeah, there's not on the actual blue finish. I think that'll probably be okay. There's probably enough glue in there. Maybe a little bit more. Just on this edge. So it's worth noting that I definitely haven't glued this support for the button mechanism in place. That's just free floating. And at the minute I'm only gluing the vertical sides. The top and the bottom will get glued on much later on in the process. So we can see if we get a bit ahead of ourselves. Just stick a bit of glue down this side and that side. That's all right. Oh yeah. Flip it over. So glue will work itself into the joints usually. So I say the main thing I'm trying to avoid is too much glue showing up on the outside of the case, because yeah, that can be really quite messy to deal with. So yeah, now I will go and just get a wet rag because a little bit has popped on here. Ooh. So with the glue setting up on those 4 internal sides, I'll just leave that to dry. And oh, I suppose the other thing I can glue on is I can glue the feet on the base. So the outside is the side which hasn't got the Raspberry Pi marked on, and these little feet are in the laser cut parts. They shouldn't need a lot of glue. I just put a little bit on. So the place I'm aiming for with these is just inside the edge, so really matching up with the same with that internal corner that's already on the ply, so like that. And the only purpose of these feet is just because the screw heads, which the bolt heads which are holding the Raspberry Pi in, just protrude a little bit from the bottom of the case. I could have used countersunk ones, but the ply is not that thick anyway. It's only 3mm, and I wasn't sure I'd be able to countersink them completely. And I could use a thicker ply, but then I could also just these feet basically just kind of give me the same effect. They slightly lift the whole button off the surface it's sitting on, allowing us allowing the screws just to stick out the bottom. So now I'm going to show you how to put the switch contacts into the button mechanism itself. The button mechanism has 3 parts. There's these 2 3D printed parts, and they go together like that. And then there's the laser cut top of the button housing, which sits between the 2 of them. So they slide through there. And ultimately these will be, the 3D printed parts will be stuck together, so this slides nicely, but for the time being we're not going to glue that right till the end. Okay. So to put the contacts into the mechanism, I'm going to use this copper tape that I bought. The first time I made a button I used thick aluminium foil from a pie tin, like a turkey tin, Christmas kind of thing. And whilst that worked, aluminium is very hard to solder to, so I've got this copper tape and I'm hoping that will be better. So it should hopefully be easier to work with as well. So the first thing we need to do is we need to put the 2 parts of the button mechanism together, 2 3D printed parts together, and then using a pen, you just need to mark where where one of these uprights on each side meets with it, and we'll use these reference lines later when we're cutting out the foil. So we can take a piece of the foil, and it's got a nice paper backing. So if I now line that up such that the edge of the foil follows the edge, it follows that little red mark we've made, and then it's quite tricky to do on camera. Sec. Okay, so they're now lined up. And whilst I hold that down, I'll take a pencil and draw around both the outside and the inside. Okay, and I can do that a second time on a second piece of foil. So again, I just line it up with the marks that I made, like that. And the marks I made are deliberately as thick as the little protrusions from the shaft of the button mechanism, and that's because I want there to be a gap between these two pieces of foil. Okay, so I've now got those, and I can now proceed to cut them out. It's worth saying that I guess these holes are going to be a bit too big because the inside lip here, there's a little thickness to it, and and generally drawing around the outside of stuff it'll get a bit wide, so I'm going to cut those out, but using it as a guide, but just come in by maybe 1.5 to 2 millimeters come in. So just using normal scissors and cut that out. On the outside edge, leaving a little bit less, maybe less than 1 millimeter, but just following that line kind of carefully. It doesn't have to be super neat. I mean, this, no one's going to see this, it's inside the button, but obviously we do want it to be a nice job. Okay, so that's one done. I can proceed to do the other one. Let's see if I can do it quicker this time. This copper foil tape is much easier to work with than the aluminium pie tin was so far. It's not pricking and cutting me, which is nice, and hopefully it will do a really good job. I suppose, so it's only just arrived in the post, so I've not had really time to play with it, so this might be a complete fail. But I suppose one thing we probably should test is that it is kind of conductive on the surface, because obviously we want our contacts to work. I have a multimeter and it's set up on beep. I don't know if I can hear that on the camera, but let's see if, because obviously I worry that this is nice and shiny, maybe it's got some sort of lacquer on it. I don't think it does, but we can test it. Yeah, so yeah, it's got a nice conductive surface, so we should have no problems. Let's see if this works. Yeah, so we should have no problems making a switch mechanism out of that. Okay, so we've got these two roundy pieces, and if we hold them up to this part, they should fit quite nicely. That's quite a neat job. Any excess that's sticking out the edge here, I can go round with a craft knife later and take off, but it's the inside edge that's really important. But yeah, so that seems to fit nicely. Let's take the other side. That's probably the one I did a bit quicker, but yeah, that still fits, and you can see there's a nice clear gap between the two, and that's important. Okay, so let's try peeling the paper off and see if these will stick. Oh, it's quite sticky. Ah! I've not peeled all the paper off because I'm a bit worried it'll get a bit out of control. That's really quite a thin piece of copper. Certainly thinner than the aluminium pie tin was. But, yeah, look, and it's smoothed down quite nice. Yeah, I'm quite happy with that. In fact, we don't even need to cut the edges off. If I just go around my thumb, it will just smooth on. Oh, that's quite lovely. Okay, so let's do the other side. Again, I don't think I want to unpeel all the backing paper just yet. So yeah, I don't know if you can see that there, but I'm just leaving the gap, which is about the thickness of one of those bits on the other model. And then let's see if we can feed that around. So this is sort of aluminium, sort of copper tape they use inside electric guitar bodies to kind of screen them from stray electrical noise and signals. So it's very, very flexible and great for like pushing into, odd shaped cavities. So yeah, it goes on there quite nice. Brilliant. So we now have those two pieces. They line up nicely with that mechanism. Yeah, that's all fine. Great. So that's only half the switch mechanism. The other half goes on this top piece. So the way this is going to work is this piece will be sitting against here. If I just flip it over this way, it's easier to visualise, but it will be the other way around. And what we're going to do is we're going to have three pieces of copper foil. Piece 1, piece 2, and a piece that goes from both sides of here, which is piece 3. And we solder a wire off on piece 1 and piece 2, and then these copper pieces on the white plastic piece, when this is pushed up against here, they bridge the gap to piece 3, which then bridges the gap in them, which then and then the other half of this piece then bridges the gap to 2. So you've got a circuit flowing from 1 across this bridge to here, across this bridge to here, across this bridge to here, and that makes a circuit. And what this means is that when we press the button, even if we don't catch every corner in a press, if it's a bit uneven, even if just one of these corners has a circuit broken on it, then the whole circuit breaks. So it's like having 4 push-to-break switches set up in series. If, on the other hand, we just had soldered a wire to this side and to this side, and then put this all copper and this all copper, that would be just one push-to-break, and we'd have to make sure we got a clean push around all sides and not one like corner was just catching. Which might be suitable for some applications where you want a really clear push, but here I wanted to be sure kids are going to be using this, they might not push it straight, so I wanted to make sure that it was quite sensitive. So again, we're going to use copper tape to put these pieces on. Oh, the multimeter's gone to sleep. And the way I'm going to do this is just like before. I'm going to offer up the copper tape, and it doesn't need to go. I'm going to use the straight edge that's already on the tape here against this straight edge here, and then I'm going to just put a little mark on here, use that to cut that to length. Okay, so that's now kind of our bridge piece that I joined there, and if I just flip that over, again holding it up, I should, all things being you should be able to just draw in the shape I want to cut out. So just have a look at that. It's a little bit wonky, but that's okay. I can work with that. Maybe I'll just shave a little bit more off that side. So yeah, that'll be our piece 3. And so that's got the join in it. So what I can do is I can just go around. I'll just cut, circle out. This piece. That's a little tricky. That's just, there we go. I suppose I could have used a craft knife. I've got the cutting board out, I suppose. That's what I should have done. Okay, so that piece will be a nice fit there, so we can try sticking that on again. Oh, let's have a go. Oh, this glue is actually quite powerful. It really sticks to my fingers. So hopefully it'll do a really good job on the internals of the button. Okay, so just got that partly in place. That round. Ooh, so you want to be careful that you don't tear. Tear it here where it's quite thin. Oh, the skull got a bit wrinkly. Let's see if I can. Okay. Yeah, because this part of the circuit here is, as I explained before, quite important because that's one of the bridging pieces. But we have got a circuit, so that's okay. If you did break the circuit there, if you did rip the foil tape, this tape's got a conductive glue. So what you could do is you could always just stick an extra piece across here. Let's see if I can. Yeah, so we could stick that there to make sure there's definitely a circuit. I mean, it probably does no harm to do that as we've got some offcuts just sitting there. Okay, so before when I was putting all this together, the camera died halfway through. So I think I just finished sticking on this extra little piece to make sure these two are definitely bridged using the conductive adhesive that's part of the tape. So they got a good side. What I did whilst the camera was dead, and I didn't quite realise, was I similarly cut 2 pieces for here and here. So it was the same idea I drew on the back of the tape. Difference being that I've left a clear gap here between these 2 contacts. So hopefully now we'll be able to, you can see that once this piece is on here, the default situation is the switch is closed and current flows. When someone presses the switch, the circuit's broken and current doesn't flow, so it's push to break. And like I explained before, even if you just catch one corner, so here the circuit's broken, but here you'd think it isn't, but because of the layout of the contacts, that would still be a successful press. So then I guess the next stage in making this is we still have to solder some wires, and they'll get soldered to here and here. But we'll come back to that later when we're doing some more of the soldering on the button. But hopefully that shows how to put together the contacts within the switch. Okay, so before we can actually get stuck into putting together the circuits and do the soldering for the button, there's a few chores we need to do. The piece of Veriboard that I've bought, whilst it's not too bad a fit for the inside of the button where it needs to go, there are some bits that hang over. So what I need to do is just lay that up and just kind of roughly mark the bits I need to cut off. So that kind of gives me a bit of an idea. Maybe I'll just do something like that. So I'll cut those off in the workshop, and I'll also drill a hole in the middle. So that's all kind of marked up and ready to go. The other chore we need to do is the LEDs I bought, the super bright ones, ultra bright, hyper bright, who knows what they are, but they come in the sort of standard LED package. If you can see that, it's, with the kind of lens on the top. If I use these in the button, then we'll get a load of little hot spots of light, so it'll be very focused light. So what I'm doing is I'm using a sander, or you can use maybe a Dremel or just something just to grind the lens off and come up with this flat topped LED. So I've got to do that to all my LEDs. The big thing to notice, and the thing to really keep on top of, is that all my red LEDs look exactly like my green LEDs. They're all clear packages. So when I've got them all out and I'm pushing them and I'm putting them into the sander, I've got to keep my piles of red LEDs and my green LEDs separate, because this whole project is based on changing the colour of the dome using different coloured LEDs. So I'll have to be really careful about that. Okay, so with all that stuff ready, we can go into the workshop and cut the boards and grind up the LEDs. So I've cut the corners off the board, I've drilled a hole in the middle, and I've started to put the LEDs in to kind of get a feel for what layout works. Again, I've been very careful not to mix up the green LEDs and the red LEDs because they look exactly the same. So at the moment these are all green LEDs, even though some of them are sitting in the locations that red ones will be. I really don't want to mix them up. So the board's basically octagonal, although some size longer than others. So what I've decided to do is go for 2 sets of 8 LEDs. So I'll put 1 LED per colour on each edge, and then I'll have an extra 2 in the middle, that'll make 10. I'll use these sort of jumper terminals, these pin terminals, so that I can use sorry, they're the same as the Raspberry Pi uses and lots of other boards use, so I can just use standard wires to connect them all up, so it should all be quite easy, plug and play, easy to test. So the first thing to check is to make sure that I'm laying everything out in line with the tracks on the bottom, which I am. And the other thing I'm going to try to do when I'm doing this is reduce the number of wires I have to actually solder in. So you'll notice that these LEDs are all in lines along with the tracks, so that I would basically just have 3 rails which I need to connect up with wires, rather than having to, if I went for more circular shape, I'd have to be bridging the tracks a bit more. So this looks like a really good way of doing it, quite a nice layout. So what I'll do is I'll use a coloured Sharpie to mark on the different tracks. So I'm going to use green for the green LEDs, and I'll also mark in, when I get to an LED, I'll also mark in the location of the LED, so like that. So if I put a green one in there, we've got another one just here. Don't need to worry too much about those at the moment. And this will really help later on when I'm putting it all together. So put some green ones in. Likewise, I'm going to do the reds, so if I mark in this line for where the reds are going to go, and there'll be one across there and one across there and across there as well. That's quite good. Now I've got also need to mark on the plus volts and the supply voltage, and because I've used red for the red LED, I can't use that, so I'm going to use blue, which is I don't know. I looked at what Sharpies I had in the box, and I decided that blue was the least confusing to use. I considered orange maybe. Black would have looked too much like the ground, but I suppose that wouldn't have been a disaster either. Okay, so now I know in the central section what's going where, so I'm going to continue to do the same for both sides as well. Okay, so now I've marked out the board and I've laid out the LEDs on it and I'm ready to solder them on. To make the process simpler and easier, I've used a piece of Play-Doh, which I've pushed the whole assembly into, and this will mean that the LEDs are held in place, so I'm able to just whiz around with the soldering iron and do the soldering. Okay, so now I've soldered up all the LEDs and all the jumping wires and things to the board that's going to go inside the button. I can now test it out. So I've just got my Raspberry Pi here, and I've just got a couple of wires connected just to the 0 volts and 3 volts on the Raspberry Pi. So if I just connect those up, you can see the green. And I connect it up the way around, so you can see the red. And you can see all the LEDs are firing, so I've not missed anything. It's all working fine. And if I just put the dome on, hopefully you can see that we're getting quite a nice diffuse light, and that's because we're using sort of translucent dome, and we're using the LEDs where we've ground the tops off. So that's all great. And now I can start thinking about putting everything together, I suppose. Oh, I suppose one other thing we have to solder is we just solder some wires onto the contacts inside the switch. So that's what I'll do now. Okay, so now we've got the light board all soldered up. and I've connected it all up to a Raspberry Pi so we can begin to test it. So let's power up the Raspberry Pi. So the switch is all soldered up as well. Because it's a push to brake switch, for testing I've just got it, the contacts sitting on it, and I'm just using this spool of solder as a little weight. If I just take that off, it will actually spring off, and that'll break the circuit. So that's okay for testing. Obviously in the real thing there'll be a sponge acting as a spring, but don't need that at the moment. We've also got a pair of sort of Darlington pair power transistors, I think, acting as a driver board for the lights. This is because the Raspberry Pi itself can't drive that much power from its GPIO, so we need some sort of interface. Darlington pair is quite a nice way of doing that. So I've got a couple of those hooked up here. Another alternative, kind of an off-the-shelf alternative, might be something like this, which is just a relay board for Arduino or Raspberry Pi. Just buy these on Amazon Prime, very easy to get hold of. My first version of the button actually used the relay boards, and they work quite nicely. The only problem is you do get an audible click when the light switches, so I wanted to see if I couldn't do a bit better than that this time around and make it quiet. So hopefully the fully solid state switching option should work. The Raspberry Pi is just booting up now, and we should see the button spring into life. Okay, so I've got the button running at the minute on a kind of faster wait time, so that it'll go red sooner than ordinarily. So it's gone red already. So if I just release the button, we get our first challenge, which is to name countries.
Name as many official United Nations countries as you can in 3 minutes. You may not use any electronic devices.
And you can see I've got the speech to text enabled, or text to speech enabled, sorry. So it's going to read out the challenges. My kids thought it was really important that the button speak, so I put that in. If you don't like it, you can always mute the telly. Yeah, so that all seems to be working fine. We'll just wait 3 minutes and see what happens. Okay, so 3 minutes up. The button says challenge complete, and the button's gone green again. And if we open the button, release it, we've cancelled the challenge, and we'll wait now a time delay. It's running quite a short time delay, so it goes red again. Press the button, and we get our next challenge.
Sort a pack of cards alphabetically by suit, then by value. Aces are low. Fastest wins. 5-minute time limit.
So we can go about doing this challenge. Once we've done it,
challenge complete. You took 21 seconds.
So it all seems to be working. The software's working, all the hardware's working, the light's going red, it's going green, the button's detecting presses. So I think we're really happy now. This can totally be all glued together. I'll glue the lights into the dome and glue the dome on and finish everything off.